Toontown Rewritten is a game run by fans of Disney's original Toontown Online. In this game, one of the ways that players can progress and bring up their health points is by playing mini-games. These include racing, gardening, fishing, and golfing. The fishing minigame provides 3 total extra health points. This game must be completed and players have to catch all 70 fish to max their health points. This is no easy task. The fishing game is tedious, and to make things worse, the game's coders are constantly updating the fishing probabilities and don't tell players what they are, to preserve the game's mystique. This is incredibly annoying for veteran players who make multiple different tunes and want to max them as soon as possible. So many players have protested by conducting their own statistical analyses to try to predict fishing probabilities in the game. My research question is, to what extent do the probabilities of catching certain fish species in Toontown now differ from past findings? The purpose of my project is to compare current fish probabilities to those found in previous studies by collecting samples of fish from the fishing minigame myself. Here is a list of fish species in the game and what they look like. Fish species can be found at different frequencies in different ponds of the game. And even though fish types look the same, like all variations of starfishes, clownfishes, etc., they are all considered different species that appear differently in different ponds. The devil ray stands alone as one of the most challenging fish to catch in the game, but a few honorable mentions are the full moonfish, baby grand piano tuna, and all starfish, which are all considered ultra rare as well. It would be nearly impossible to catch enough of these fish to perform accurate statistical inference on them, which also contributes to the challenge of finding and catching them. There are several major ponds in the game, each with different themed sections of the map and each with different fish and probabilities of catching them. They are the Toontown Central Pond, Donald's Dock Pond, the Daisy Gardens Pond, the Minnie's Melodyland Pond, the Berg Pond, the Donald's Dreamland Pond, and the Estate Pond. I focused on 3 different pieces of research for this project, which led me to asking 3 smaller questions, which are: has the probability of catching a starfish significantly changed from 2009? Have the chances of catching fish rarities significantly changed since 2015? And have the chances of catching a boot changed significantly since 2004? I collected my data by playing the fishing minigame in each major pond in the game, marking an Excel spreadsheet when I completed a trial or caught a fish of interest, and then compiling my data in a table. The basis for the first question was on the proportion of catching a starfish in 2009, specifically in the Toontown Central Pond, so I also collected starfish from this pond. To answer the second question, I collected pool sharks from each pond in the game and compared the probability of catching them to the 2015 probability of catching all fish with the same rarity. The pool shark is rarity 3 out of 10. And finally, to answer question 3, I collected boots from every pond in the game and compared my boot probability to the probability of catching a boot found by a player in 2004. In the game, catching a fish looks like this, where the player aims at moving shadows by dragging back the mouse at a certain distance in a certain direction. This varies in difficulty depending on how erratically the shadows are moving and how much space they have to move around in. But none of this affects the actual results of the catch, which is entirely determined by the computer and predetermined probabilities for each pond. After a fish is caught, the game gives you the fish's name, animation, weight, and value in the game. Additionally, 1 more fish is added to your bucket, and when you reach 20, you have to leave to sell them and come back to fish again. Throughout this process, I caught an estimated 900 fish and filled an estimated 45 buckets. Here's what my Excel sheet looked like. I put an X for each trial where I caught a fish that I was not interested in, and a purple box represented me catching a certain fish of interest. Additionally, I used green boxes to represent the sample size that I thought I would need to meet the success-failure condition. I marked the Excel spreadsheet at the same time as I played by keeping my tab open like this. To make inferences for this data, I had to check the assumptions and conditions for 2 proportion z-tests and intervals. The independent group's condition was satisfied because my data have no way of overlapping with the data found by players in the past. The randomization and 10% conditions were satisfied because the game gives a random fish for each time the player hits a shadow with their fishing rod, and there are indefinitely many possible fish to be caught within this population. And finally, the success-failure condition was met for each part because I was able to manipulate the probabilities found by players to give a proportion of at least 10 out of the sample size, and for my own catches, I made sure that I had at least 10 of the fish of interest. For question 1, which is, have the probability of catching a starfish significantly changed from 2009, a player on an online forum gave an in-depth overview of how fishing probability works and cited an exterior and now deleted source to give the probability of catching a starfish in the Toontown Central Pond to be 15.96%, or 10 out of 63. I fished the pond myself, and my observed proportion was 25 out of 142, or 17.61%. Here are my mechanics. A hypothesis test of this data found a p-value too large to reject the null hypothesis that there is no difference in the probabilities of catching a starfish in 2009 and now, which was supported by a 95% confidence interval that included 0. For question 2, which is, have the chances of catching fish rarities significantly changed since 2015, a player supposedly found accurate probabilities for each of the fishing rarities from 1 to 10 in the game. I randomly selected Rarity 3 to be my focus, and then randomly selected the Rarity 3 fish, the pool shark. The proportion given in 2015 for pool sharks and other Rarity 3 fish was 10 out of 25, or 40%. I fished for these in every major pond in the game, and my observed proportion was 16 out of 641, or 2.5%. Here are my mechanics. A hypothesis test of this data gave a p-value small enough to reject the null hypothesis that there is no difference in the proportions of Rarity 3 fish from 2015 and now. A 95% confidence interval that did not include 0 and showed a positive difference between the 2015 proportion and the present proportion supported this rejection of the null hypothesis. For question 3, which is, have the chances of catching a boot changed significantly since 2004, a player performed an exploratory analysis of the fishing game and found a proportion of 70 boots out of 1,082 total catches. I fished every pond in the game as well, and my observed proportion was 66 out of 875. Here are my mechanics. A hypothesis test of this data gave a p-value too large to reject the null hypothesis at the 0.05 significance level, and this was supported by a 95% confidence interval that included 0. To conclude, although the game's website frequently mentions changed fish probabilities, the majority of my research illustrates no significant changes to the fishing probabilities, if any at all. The one part of my project that showed a significant difference was the rarity section, and implies that the way rarities are defined may have changed since 2015. But it is also important to note that the person who conducted that study, and also both of the other players from 2009 and 2004 who conducted their own studies, could have been inaccurate or introduced their own biases into their findings that I haven't been able to account for in my project. Unfortunately, there is no way to go back to the original fishing game from these time periods and test the probabilities myself, so I have to rely on the others' data. Overall, since fishing difficulty varied by pond and meeting the success-failure condition meant catching at least 10 of each fish, it was challenging to catch the amount of fish that I wanted within the time constraints. For example, this project may not be as representative of fish of higher rarities, because a devil ray, at rarity 10, for example, takes tens of thousands of catches to get only one, and I would have needed to get 10 to make inferences with it. Additionally, I wanted to perform inference with one fish representing each rarity, and even adding a section in the project where I compare each pond to past research using Kai tests. It also would have been nice to try comparing the Fish Advisor app to one fish from each pond in the game, and then making 7 different hypothesis tests and intervals. These would be great extensions of my research, and since I have a large personal investment in the game, I might perform them myself later on using the techniques that I have learned in this class. Thank you.